We want to find the arc length of the spiral given by the parametric equations for t on the closed interval from 0 to 2. Let's begin by looking at this graphically. The graph of the spiral looks like this, and when t equals 0, we'd be at this point on the spiral, and when t equals 2, we'd be at this point on the spiral. So the distance from this point to this point along the curve, or the length of this piece of the spiral, is the arc length we're trying to find. So again, if we start at this point and travel to the second point along the curve, the distance traveled is equal to the arc length we're trying to find. The arc length is equal to the integral of the square root of the quantity x prime of t squared plus y prime of t squared integrated from a to b, or in our case, from 0 to 2. Let's begin by determining x prime of t and y prime of t. Notice how both of these functions are products of two functions, so we'll have to apply the product rule. So x prime of t is equal to the first function e to the 2t times the derivative of the second function. The derivative of cosine t is negative sine t, plus the second function cosine t times the derivative of the first function, or e to the 2t, that would be e to the 2t times the derivative of 2t, which is 2. So simplifying, we have negative e to the 2t sine t plus 2 e to the 2t cosine t. Again, this is x prime of t, which we'll be using in the arc length formula after we find y prime of t. So y prime of t also requires a product rule. So we'd have the first function e to the 2t times the derivative of the second function. The derivative of sine t is cosine t, plus the second function sine t times the derivative of the first function, or the derivative of e to the 2t, which is e to the 2t times 2. Again, simplifying, we have y prime of t equals e to the 2t cosine t plus 2 e to the 2t sine t. And now we can set up the integral to determine the arc length. The arc length s is equal to the integral of the square root of, again, x prime of t squared. So we'd have negative e to the 2t sine t plus 2 e to the 2t cosine t. This is all squared, plus y prime of t squared, which is e to the 2t cosine t, plus 2 e to the 2t sine t. And again, this is all squared. And we're integrating on the interval from 0 to 2. Let's begin simplifying the radicand on the next slide. Let's begin by squaring this, and simplifying. So there's no shortcut to square this. We have to write out the factor twice. Notice how we'll have four products: 1, 2, 3, and 4. Notice for the first product, we'd have a negative times a negative, that's positive, and then we'd have e to the 4t. When multiplying, the bases are the same, we add the exponents, and then we have sine squared t. For the second product, we would have negative or minus 2 e to the 4t sine t times cosine t. For the third product, we would have negative or minus 2 e to the 4t, again, sine t times cosine t. And then finally, for the fourth product, we would have plus 4 e to the 4t cosine squared t. Notice how these two middle terms are like terms. So we have the arc length s equals the integral from 0 to 2 of the square root Again, this squared would be e to the 4t sine squared t. And then we have minus 4 e to the 4t sine t cosine t. And then we have plus 4 e to the 4t cosine squared t. And now from here we have to square this and then finally simplify the radicand. So to square this, we'll have these two factors, and again we'll have four products. 1, 2, 3, and 4. To save some time, I'm going to quickly work this out. Just as before, these two middle terms are like terms, so we can combine this to three terms. So we'll add these three terms under our square root. So we'd have plus e to the 4t cosine squared t plus 4 e to the 4t sine t cosine t, and then plus 4 e to the 4t sine squared t. From here, notice how these two terms are opposites, and therefore they sum to 0. And then from here, notice that these two terms share a common factor of e raised to the power of 4t. So let's go ahead and write those in factored form. If we factor out e to the 4t just from those two terms, we'd have e to the power of 4t times sine squared t plus cosine squared t. And then the remaining two terms, these two terms here, share a common factor of 4 e to the 4t. So we'll factor out 4 e to the 4t just from these two terms. So we'd have plus 4 e to the 4t times the quantity cosine squared t plus sine squared t. And we should recognize the identity here. Sine squared t plus cosine squared t simplifies to 1, and of course so does cosine squared t plus sine squared t. So we have the arc length s equals the integral from 0 to 2 of the square root of, this would just be 1 e to the 4t plus 4 e to the 4t, which would be 5 e to the 4t, which of course we can write as integral from 0 to 2 of the square root of 5 times the square root of e to the 4t. Let's factor the square root of 5 out. So we'd have the square root of 5 times integral from 0 to 2 of the square root of e raised to the power of 4t. Remember, e to the 4t is equal to e to the 2t times e to the 2t. So the square root of e to the 4t is just e to the 2t. So we have the integral of e to the 2t integrated with respect to t, again from 0 to 2. Let's go ahead and finish this on the next slide. Here we'll have to perform u substitution, where u is equal to 2t, differential u equals 2 dt. So dividing both sides by 2, we have 1/2 du equals dt. So we'll have an extra factor of 1/2 when integrating here. If we write this in terms of u, we can write this as the square root of 5 times integral of e to the u. But again, dt is equal to 1/2 du. So we can put the du here and factor out the 1/2. If we want to leave this in terms of u, we'd have to change the limits of integration. Let's go ahead and do that. Notice when t is 0, u is 2 times 0 or 0. And when t is 2, u is equal to 2 times 2 or 4. So we would have square root of 5 divided by 2 times e to the u. And again, the limits of integration are from 0 to 4. So we have square root 5 divided by 2 times, when u is 4, we have e to the 4th minus, when u is 0, we have e to the 0. So the exact arc length would be the square root of 5 divided by 2 times the quantity e to the 4th minus e to the 0, which is equal to 1. So this would be the exact arc length. Let's also get our decimal approximation. So we'd have the square root of 5, right arrow, divided by 2, open parenthesis, e, second natural log brings up e raised to the power of 4, right arrow, minus 1, close parenthesis, and enter. So the arc length is approximately 59.9246 units. If we go back to the graph one more time, we just determined the arc length from this point when t equals 0 to this point when t equals 2, which again would be the distance the point travels from this point to this point, as we see here along the curve. I hope you found this helpful.